কখন স্টার্ট করতে হবে বলবেন? দেখতে পাচ্ছি না তো কিছু। So, I welcome you all to this live session for the course Switching Circuits and Logic Design. Now, this course has been running for the last 7 weeks, the 8th week is now running. So, we are having a live session here today. So, whoever is online today, we shall be taking some questions from you and we shall be trying to discuss. But first, before that, I have already compiled some of the queries which some of you have already posted on the Google Doc which was shared with you. Let me first discuss a few of those questions that were posted, and after that we shall be coming back to the online questions that you may be having. Okay. So, here we have this live session. The first type of query that I received, this was not really a technical question. There were two parts in this question. Actually, there are two different queries. The query was to get complete knowledge of this course, what are the additional courses we need to do for better future jobs in this field. And the second question was, I would like to become a VLSI designer. Could you please tell me how this course will be useful for VLSI design? Is this course sufficient for it? Okay, you see, when you are doing this course, this is a first level course in digital circuit design. This course is typically taught in the second year level in the computer science, electronics or electrical engineering curriculum. So, when you are doing this course, just not think at all about jobs. This is a very fundamental and basic level course. This course alone will never give you any job, okay? Keep it simple. So, you have to build some skill set based on which you can possibly put forward your candidature for a job. For example, there was a question on VLSI design. Well, in addition to this course, this is of course a very fundamental level course. Some of the courses I have listed here, of course, this is not the exhaustive list. Some course on computer organization, computer architecture, digital system design, VLSI system design, VLSI physical design or computer-aided design for VLSI. These courses are all available, embedded systems. So, you need to do all these courses, you need to develop the skill set in these courses. There are again some courses on FPGA based design. So, how to design digital circuits and systems using FPGA systems and boards and so on and so forth. So, once you do all these things, then you may consider yourself capable that you know something about digital design. Now, you can put forward your candidature that, well, I am now ready for the job market, you can seek for jobs after that. Okay? Fine. All right. There was a question like this. This is with respect to Karnaugh map. The question said, in Karnaugh map, can't I combine a minterm which is already combined with other with minterm that is not combined with any other to form bigger cube, but answer varies sometime if I combine. The question is a little, you can say, jumbled up, but let me try to explain what the person actually meant. But before that, you should remember that when you do Karnaugh map minimization, when you do the covering, form the cubes, there are three basic considerations you need to look at. First one is that all the true minterms of the function must be covered. Second is that the number of total number of cubes should be minimum, because each cube will correspond to one product term in the sum of products expression. So, if you minimize the number of product terms, it will also minimize the number of product terms in your final minimized expression. And thirdly, the cube that you form should be as large as possible. Larger cube means fewer number of literals in the product terms. Okay? Now, with respect to the question, let me look at an example. Suppose we have an example where these are the true minterms. Suppose there are 4 true minterms here, there are true minterms here and there is one true minterm here, and you need to cover all of them. Okay. So, according to the question, what the person actually meant is that, you see, this is naturally one cube you can form, and this is the biggest possible cube you can form. Another cube you can form like this with these two. So, here there is no confusion, but for this middle one there are 2 ways you can do it. There is already one cube which is formed, you can combine this with that. Similarly, that means you can either combine this with this like this, or you can possibly combine this like this. These are 2 ways you can combine. You can choose any one of them, and depending on which one you are choosing, your final sum of product expression will be different, but both will be minimized, both will be in minimized form. Okay. So, your question said, but answer varies sometimes if I combine. Yes, of course, the answer will vary depending upon which cube you finally select. Suppose I choose this cube, then the answer will be something. If I choose the other one, then answer will be something else. But the bottom line is that I need to obtain the minimum form of the expression, I need to minimize the expression. Both option will give you a similar minimum form of expression containing 3 product terms, right. So, this is with respect to this query. There is another query again related to Karnaugh map. It said that how can you make Karnaugh map for variables more than 5? Well, with respect to Karnaugh map, up to 4 variables it is easy, but as you go beyond 4 it becomes difficult. 5, 6, beyond 6 it is impossible. So, you can at most go up to 6 variables with respect to Karnaugh maps. Here I am showing, for example, a 5 variable Karnaugh map. Here as if there are 2 4 variable Karnaugh map which are sitting side by side. If you look at it, 2 of the variables a b, this a b, they are along the rows, and 3 of the variables c d e, they are along the columns. This makes 5 variables. And if you see the way we have numbered the columns 0 0 0 0 0 1 0 0 1 1 0 1 0, and these two you see, these two are adjacent, they differ in a single value 0 1 0 1 1 0, differs in the first one. So, the way we are placing it, the adjacent minterms, they are neighbors, you can combine them into a cube if you want. This is the way we are putting it. That means, if you want, you can make a cube like this, if you want you can make a cube like this. Okay. This is how you can make a 5 variable Karnaugh map. Similarly, you can extend it to 6 variable. Beyond 6 you really cannot visualize, that is why we do not do beyond 6 variable. 6 variable Karnaugh map looks something like this. Here there are 4 such 4 variable Karnaugh map, we have placed it side by side in row and column. You see along the rows there are 3 variables a, c and d. Similarly, along the columns there are again 3 variables b, e and f. So, again the way we have placed the variables and numbered these cubes, the adjacency is maintained. Like I can make a cube like this, I can make a cube like this if I want. Okay. I can make a cube like this. So, if you consider a 6 variable function and construct a 6 variable Karnaugh map like this, again following the adjacency rules, you can carry out minimization, you can obtain the minimum sum of product expression. Okay. So, it is quite similar, but beyond 6 you really cannot draw such a curve. where all adjacencies can be captured, it will become 3 dimensional, it will grow in the other direction. So, beyond 6 variables we do not use Karnaugh map, we have to use some method like the Quinn-McCluskey method, the tabular method that you have studied, methods like that. Okay. Well, one of you asked, okay, this was a very general kind of a question, I do not consider it to be a very focused question in that sense, that I want clear and easy explanation for latches and flip-flops and latches. You see, if you want clear and easy expression, you should read a book. There are so many good textbooks available on this subject. You read a book, you will get all the detailed explanation. In terms of the functionality, I can only tell what is the essential difference between a flip-flop and a latch. You see, in a flip-flop, if you consider a flip-flop as a black box, there will be some input, there will be some output, and there will be a clock input. Now, when the clock comes, means some active edge of the clock, either the rising edge or the falling edge. When the active edge of the clock comes, at that point in time, whatever input you have applied here, that value will be captured, and accordingly this flip-flop will operate and the output will be obtained. But between the two active clock edges, if the input changes, nothing will happen to the flip-flop, the output will remain stable. Suppose it is rising edge triggered, I have a clock like this, another clock like this is one rising edge, this is another rising edge. Now, in between, if your input changes, there will be no effect on the flip-flop, there will be no change, output will not change. Only when the active edge comes, at that point in time, whatever input values are there, depending on that, the output will be determined. Okay. Similarly, for a latch, conceptually it looks similar, there is an input, there is an output, but instead of a clock, there is some kind of an enable input, you can call an enable input. Now, a latch works in this fashion, there is nothing like an active edge of the enable input. Enable will be either 0 or 1. Let us say the latch will be active when enable is equal to 1. Let us assume when enable is at 1, the latch is active. So, as long as the enable is 1, as long as it is high, whatever input changes, that change will be immediately captured. So, if the input is changing, the output will also change in between, as long as the enable remains high. But once enable is 0, then again there will be no effect. If the input changes, nothing will happen. This is the main difference between flip-flop and latch. Flip-flop is edge triggered, rising edge or falling edge. Latch we say it is level triggered. As long as it is active at a level, let us say high, the latch will be open. Whatever is coming, that will get stored. Okay. So, this is the main difference. I got another question. This basically is a confusion some of you are having. I also looked at some of the queries in the forum. This relates to Moore's law. Now, what we said Moore's law, in Moore's law? Moore's law says that with every passing year, the number of components or transistors in a chip is increasing. Moore's law says the number of transistor gets doubled every 18 months or so. Okay. And so, the question was, according to Moore's law, for 10 years number of transistor per unit area are doubling for every 18 months, fine. Now, the person says, so it is linear increment for 10 years. Here there is a confusion, it is not linear increment, you are wrong. If something doubles in constant amounts of time, it is actually exponential growth and not linear growth. I am explaining why it is. The idea is, if the number doubles every fixed duration of time, this is exponential growth, not linear. Why? Let me take a simple example. Instead of 18 months, let us say that it is 2 years. let us say for every 2 years the number is doubling, let us say because 2 years is easy to calculate. Okay. Or in this example not 2 years, let us say it doubles every 1 year, let us say it doubles every 1 year. In this example I have assumed 1 year. Let us assume the number doubles every 1 year. So, what happens? Suppose initially the number is 1000. So, after 1 year it will become 2000, after 2 years it will become 4000, after 3 years it will become 8000, 4 years it will become 16,000. You see most like something similar, instead of 1 year it is 18 months, 18 months is that unit. I am consider that 18 months to be 1, 2, 3, 4, 18, 36, 54 like that 72. Now, this kind of a growth you can represent by an equation like this, 1000 multiplied by 2 to the power year number. If year is 1, 2 to the power 1 is 2, 2000. If year is 2, 2 square 4000, year is 3, 8000. 2 to the power something, this is exponential, this is not linear. We say something is linear if it is some constant multiplied by, let us say in this case year is the variable multiplied by year, but here it is 2 to the power year proportional to some constant to the power time, that is why this is exponential. Okay. So, these are the questions that I received online before, but now I got a few other questions. Let me try to explain these. Okay. Just a second. Fine. There is a question on the Reed-Muller form or Reed-Muller expression. Okay. Let me try to explain this. Just a second, let me try to open a new page, it is not opening. Let me try it. Fine, anyway, do not worry, I am just trying to explain here only. Reed-Muller expression, what it is? You see, when we normally write a function in sum of products form, actually how do we write? We write it something like this, f equal to a b or let us say b bar c d, something like this. There are some product terms which are and of some literals variable. Literal means a variable or its complement. A b is one product term, b bar c d is another product term, and there is or, the product terms are or. This is called sum of products expression. Now, Reed-Muller expression says that instead of or we use exclusive or. Suppose I have a function like this which I express like this, let us say one exclusive, this is a symbol for exclusive or. Let us say A exclusive or A B exclusive or B C D, something like this. This is what is meant by Reed-Muller form. In Reed-Muller form, we again have some product terms. Let us say A is a product term, A B is a product term, B C D is a product term, but instead of being connected by plus or, they are connected by exclusive or. So, if you directly map this function into gate level circuits, a conventional sum of product form you can map it in terms of AND gates and OR gates, right. Here there will be one AND gate for A B, one AND gate for B bar C D and OR of these two. But for Reed-Muller canonical expression, there will be some AND gates all right, but there will be exclusive OR gates, not OR gates. Now, in terms of performance, Reed-Muller canonical expression is not used because they will be slow. Exclusive OR gates are much slower as compared to OR gates, but they have some very nice properties. Well, we have not discussed this as part of this course, that when you design a circuit, one important part of it is how to test the circuit, how to check whether it is working correctly or not. Now, if a circuit is designed using AND and exclusive OR gates, it has been found that the circuit can be tested very easily and very efficiently. Okay. So, that is why we go for Reed-Muller canonical expression. In fact, there has been a lot of research on Reed-Muller canonical expression. The main reason or main purpose of the research was how to easily test a circuit. But in terms of the actual implementation, if you see the circuits that are designed, the chips that are fabricated, no one implements Reed-Muller canonical expression because they are more expensive and they will be slower in terms of speed. So, AND or NAND kind of expressions are more widely used. Okay? Fine. Now, here there is a question which relates to one query that was posted in the discussion forum. Actually, I do not want to discuss it here because the other persons who are listening, they have not seen the problem. This was a problem related to a book rack. The question was something like this, that there is a book rack, there are certain number of books in the rack. You look at the days of a week, Monday, Tuesday, Wednesday. Let us say on Monday, I take out 3 books. On Tuesday, I take out 2 more books. On Wednesday, I add 3 more books. So, with time, the number of books is either increasing or decreasing. So, the question was how I can model this as a finite state machine and how I can design the state transition diagram. Well, I only gave an idea because this was not discussed in the slide, that is why I did not discuss it in detail, but if you want I will post a detailed solution on the forum. Now, the idea I am telling you, here we define the different states as the days of the week. Okay. Now, each state will indicate how many books are there in the rack. Let us say this is state A. Okay. Now, A may indicate that the number of books is 10 and A indicates that it is Monday. On Monday, this is the status, and on Tuesday I move to state B. I take out 3 books. So, B indicates the number of books is 7. So, this is the meaning of the states. You should remember what is the meaning of the states. On next day, let us say this is Monday, Tuesday, Wednesday, let us say C is Wednesday. Wednesday I take out another 2 books. So, C will indicate 5. D is the next day. Suppose here I again put back 3 more books in the shelf. So, D will indicate 8. So, I can model the finite state machine like this. Depending on exactly what the problem is, you can actually design a finite state machine for this. Well, the detailed design we can post it, but I would request the person to actually clearly specify the problem, because the problem was a little incomplete. You post the problem in a complete way, then I can work out and I can post the solution in the forum, right. Okay. There is another question, this is related to the final exam. It says that the final exam questions, will it be based only on lecture videos or any extra textbook to refer? You see, in the lecture videos we have explained some concepts. In the exam we can give you some problems which you should be able to solve once your concepts are clear. Do not expect that the same problems that you have solved, the same kind of questions will be given, or the same assignments which are given, that same thing will be repeated, not like that. Once your concepts are clear, for example, Karnaugh map, once you know how to minimize functions, then we can give any problem on minimization, you will be you should be able to solve, you should be able to do. In your final exam, questions will be like this. Of course, we would always recommend you should read books. These video lectures are only to provide you some guidance regarding the basic concepts, but these are not complete in any sense. This is why we have also referred some textbooks in the beginning, in the main course page. You should read textbooks, whatever doubts you may be having, because you see in the lectures you are not having one-to-one interaction with the teacher. If you are having some doubts, you are not able to clear the doubts immediately. You should try and read the books, you should try and clarify the doubts immediately. Okay? That way your concept will be very clear, and I am sure you would be able to secure very good marks in the examination. You should be able to do and perform very well. Okay? And which book is the best one? I have already referred to some book. Well, in our courses, for example, the main textbook that we refer is a book by Kohavi and Jha. There is a author Kohavi and Jha. The name of the book is Switching and Finite Automata Theory, but this is a very good book on switching circuits and digital design. In fact, there are many other books. This is, if you want one book, I shall recommend this, because this is a very old and authentic book, and this is a very good book as well. In our second year level course in computer science department, we follow this book mostly. Okay. So, if you have any other queries, you can post, I can try to answer. Now, in the meantime, let me also talk about a few other things. Well, I have not received any query for this course, but in other courses which also I am handling, similar questions are there. Some of you are asking that what is the scope for internship in the future. If you want to do internship in one of the IITs and some good institutions, can NPTEL help? Well, NPTEL has a very well defined policy in this. For every course that are running, for example, let us talk about this course, switching circuits and logic design. The top 5% or means the top 5% performers, the top performers in terms of the performance, if I consider the top 5% of the students, they will be given an opportunity to do internship in one of the top institutions like IITs. Okay. Of course, depending on the availability of the professors, which IIT you would be doing, that will be coordinated by NPTEL. You can directly contact them and they will tell you what to do, how to do. Okay. And talking about research in this domain, there is a query again that to throw some light regarding research in this domain. Let me tell you here. That this is gone na? Okay. Okay, okay. Oh, fine, fine. There have been some glitch in the network, that is why I stopped. Okay. The query was to throw some light regarding research in this area. You see, as I told you, the switching circuits and logic design, digital circuits, digital electronics, there are various names that are given to very similar courses that are run in the various departments. The course coverage is very similar. Now, as I told you, this is a very basic level course which is typically run in the second or third year levels. Sorry. Okay. Now, at the second year level, we usually do not talk about research, we build foundations. We gather our knowledge, we proceed further, and beyond a point, third year level, fourth year, when you have done a number of other courses as well, you have some fair idea regarding some possible research directions. But in this particular course, if you look at, deliberately I have tried to talk about a few problems or few areas which are, you can say, some kind of research areas, something which is new. Let us take some examples. You think of the all optical design of logic circuits. I talk about Mach-Zehnder interferometer, although very briefly, but this is an area of research. How to realize logic circuits, do logic design using all optical circuits. Then I talked about memristors. Memristor is an emerging technology which is coming up. Maybe in the near future we will be seeing some products based on memristors hitting the market. Now, using memristors you can design memories, memory systems. These are called resistive memories, and inside that same memory system you can also carry out logic design, like some of the methods that I discussed in the lectures. So, these are some of the new and emerging technologies, and these are research areas, research topics. Then I discussed about BDDs, binary decision diagrams. Well, BDD is a basic concepts, but based on BDD there are many other things, many other areas where people are doing research on. Ways of efficiently representing functions, verification of two functions, how to verify whether they are same or not, minimization of functions. There are a number of different areas where people have been carrying out research in these areas. Okay. So, I have tried to touch on a few such areas which are not part of a normal second year curriculum in any institute, but I have deliberately tried to touch them because I wanted some of you who are interested to get at least a flavor about what is new and what you can do possibly in the future, like as you have asked, some possible research topic. Okay. And there is another query, this is again related to the examination. This question says, will I be able to solve the final exam question if I read the assignment questions and the lecture materials? Well, I should not say only read and understand clearly. If you have understood clearly, if you have gone through the lecture materials, understood the concepts clearly, if you have done the assignments, understood the problems, how to solve them, then you should be able to perform well in the examination. It should not be a problem. Okay. That is why I should not say only reading the materials, reading and understanding. And for that the supplementary reading materials or books are important. Whenever you face any doubt, instead of only asking in the forum, you should try to clear that doubt yourself first. There are some reference books which are suggested, you read in the book. I am sure that the exact doubt that you would be having at some point in time, it would get clarified, but even if it is not get clarified, then we are here to help you out. You can post your doubt or query in the forum and we can try to solve it. Okay. So, actually this is how things move on. I believe broadly speaking these are the things. For the examination you do not worry too much, try to follow the video lectures, try to solve the assignments, and again wherever you have doubts, read books. Do not assume that these lecture notes and slides whichever there, this is all. This is just we are using slides to explain the topics to you. but you may be having doubts always. You should read books, you should refer to additional materials. There are numerous materials in the web. If you do a Google search, you will get almost everything. Okay? So, you should see and look at materials which are available and try to clarify some of the doubts that you are having yourself. So, let us see if there are some additional queries coming. I think one more is coming. Yeah. Does microprocessor not come under this course? No, microprocessor does not come under this course. If you look at any general course at the second year level in BTech, normally I am talking of computer science, electrical engineering, electronics. This course which we are talking about here, this is known by various names. Like this particular course, I have chosen the name digital switching circuits and logic design. In some department, the same kind of course is run by the name digital circuits, digital logic, okay? Switching circuits, various names are there. These will give you a basic understanding about how to design digital circuits, how to design combination circuits and sequential circuits. Now, your question is microprocessor. Microprocessor is one step ahead. With the background of how to design digital circuits, the next thing you will have to learn is something called computer architecture or computer organization. How a computer system is built, what are the basic building blocks in a computer, how a computer works. Microprocessor is an example of a computer. Okay? So, logically speaking, the course on microprocessor should come after computer organization is taught. After you understand how a computer system works, then you can very well understand what is a microprocessor. Means a computer in a single chip, that means the processor, the CPU inside a single chip. Okay? So, how it works, what are the different kinds of microprocessor, what are its features, but this topic on microprocessor will not be covered in this particular course. There are other courses that are running under the NPTEL platform which covers microprocessors and microcontrollers. You can just refer to those courses if you want to know about these. Okay. So, this course is just a fundamental level courses where we try to teach you how to design combination circuits, how to design sequential circuits, that is it. Okay. So, if you do not have any further queries, we can close the live session today. Let us look forward and have some more live session before our final examination once more at least. Okay. Let us try to organize another live session in the near future. And as I said, you follow the lectures well, try to understand what is being covered. Well, you see, in some of the slides when I am writing, there can be some typographic errors, there can always be some mistakes. So, wherever there are errors, we will just tell you that here there are some errors, just ignore that and just to try to understand what is correct and what is wrong. Okay? And you try to solve the problems. The assignments are only some guidelines, some simple problems we are giving. Read books, books are always recommended. You must read books to gain additional knowledge, and means I wish you all the best for the course in your next weeks, the remaining 4 weeks, at least the 8th week is already started. So, 5 more weeks are there. So, I wish you all the best for the remaining weeks. Thank you. Right. Yeah, I have already.